let's start off with the session for today. Uh, Practically, this is the first class of CFA level 2. The reason being that before this we had an orientation. I've shared an orientation video where I have shared in detail what are the changes in format, the weightage of each and every subject, exam wise, what are the possible structures in exam which are possible. So Vinet set has either you will get a 4 question or a 6 question in every Vinet, and then based on the number of questions, what is the various permutations and combination. There were 3 permutation and combination of an exam format which is possible. That also we discussed. What are the challenges that you will see in level 2 compared to level 1? How is it different? That also we discussed, and we also discussed about the resources that will follow and the time that is required. Each and every granular detail, basically a orientation or an introduction to level 2, that we have that video I have already shared with you. So hopefully you have watched that video, because before starting level 2 that will give you a complete overview of how level 2 is different from level 1, and how you need to, what are the areas in which you have to now upgrade yourself, or you can say adjust yourself to the level 2 format of exam. So that is something which we have already discussed. If you have not watched that video, I would strongly suggest do watch that video. I think that's not more than a 1.5 hour video, but that is going to give you a very detailed analysis and overview of the weightage and each and everything that you require to know before starting a level 2 session, okay, or level 2 preparation. Okay, now coming to the next part, the first subject that we are starting today is quants. Okay, 1 second. So first subject that we are starting today is quants, and in quants, this is the first class with which we are starting off with reading 2, not reading 1, reading 2, which is multiple regression, This is the first topic that we are picking up. Okay, now why are we not doing reading 1 and why we are directly starting with reading 2? The reason is very clear, that in CFA this reading 1, the name is Introduction to Linear Regression, and that particular reading is a common reading. If you look at 2022 syllabus, then that is a common reading for CFA L1 and CFA L2. That was the last reading of CFA L1 quants, and that is the first reading of CFA L2 quants. There is a symbol, or there is a message that institute is trying to communicate with. Hello, hi Garima.
Hi Mohit.
Okay, we have just started, Garima, so you can. Okay.
Okay.
Yeah. So I was saying that the reading 1 is Introduction to Linear Regression, and that is common. If you look at the 2022 syllabus, then the quants last reading, CFA level 1 last reading is Introduction to Linear Regression, and CFA level 2 first reading 1 is also Introduction to Linear Regression, and it is 100% same. It is same. What message institute is trying to tell us? The message institute is trying to tell us is that, sir, please don't be confused that when you are moving into level 2, you will forget all the concepts of level 1. No, that is not the way it's going to work. When you are moving into level 2, all the knowledge and all the concepts of level 2 can be tested in any format, whichever is there. It does not mean that you have, when you are preparing for level 2, you will have to go back to level 1. No, I'm not saying that. What I'm trying to communicate over here is that when you will study the content of level 2, today only you will see that there will be there will be some concepts of level 1 which will repeatedly keep on applying. For example, when we will do today multiple regression, then hypothesis testing, which is not a concept in level 2, it was a concept in level 1, it will get applied. You will have to perform hypothesis testing. So what is the message institute is trying to give us? Message institute is trying to give us is that level 1 and level 2 is not disconnected. It is like a series, or it is like a chain where knowledge of level 1 will be required in level 2 in different ways, in bits and pieces. Okay, so how to tackle that thing, that also I will cover during my session. So you don't have to go and read the entire book of level 1. I know that is not possible, but how to tackle that part where the concept, which concepts of level 1 we may have to relook at, all those things I will be guiding you as we proceed ahead. But this is message is very very clear. Even that same thing you will see in other subjects also, where the application or the concept or the reference of CFA level 1 content will repeatedly come in our level 2 content. And institute, when while referring to the level 1 content, has presumed that you have sufficient knowledge. So in case you feel a disconnect, I would suggest you can discuss with me, or I would suggest that you can refer that particular portion from level 1 content, just that portion, not reading the entire reading or not reading the entire subject, just that particular portion. Okay, that's why I told that it for today's session it would be highly beneficial for you that you can watch the my lectures for linear regression, the 3 lectures for linear regression, which covers reading 1, which was taken from CFA level 1 only, because as I told, the level 1 and level 2 syllabus or the reading is entirely same. So those lectures are workable in level 1 as well as in level 2 for that particular reading only. Okay, apart from that, hypothesis testing is also there. Before I start with the content part, hypothesis testing will also be there. So in case you feel that you need to go over the hypothesis testing concept again, my videos of level 1 will always be available to you for watching of hypothesis or other content as well. So for those candidates who are taking the level 2 syllabus with us, the level 1 content will also be available with them, not the entire content, but the content which has its application in level 2. So for example, if I say from Quants perspective, hypothesis testing and linear regression is any which way is part, but hypothesis testing is also required. So in case there is someone who has not read hypothesis testing in detail in level 1 but somehow managed to clear the exam, but now you will not be able to do that same thing again. So you will need required knowledge, and to, if you want, you can access our level 1 lectures also. That benefit will be there. Okay, so that is something. The format in which I am looking to navigate further primarily will be that we will be completing an entire reading. You are expected to complete that entire reading along with me. Okay, because majorly everything will be covering in the live online session only. So you will be covering that entire reading with me, post which I am looking to solve at least 2 or 3 Vinet or item set together. So that we'll try to do, and we'll solve the Vinet together, because my only purpose here, compared to level 1 where there were individual questions, here we are getting a item set based or Vinet format question, which I would like you to be oriented with how to approach Vinet format questions, how to solve those questions, everything we have to do, and I have to explain in detail. So that is why at least for the few initial topics, and if possible for the entire syllabus, we will be solving 2 or 3 minutes as well, so that you guys are oriented with the format, you guys are oriented and have sufficient knowledge and have developed the approach to solve the Vinet based questions in the most effective manner possible. Okay, so this is a broad layout of how we are going to navigate. To sum up, number 1, level 1 content may find its application in level 2 again. So it does not mean that you need to go back in level 1 and read the entire book of Quants. No, but I will specifically give you those level 1 concepts which may find this application in level 2 for Quants. I am straight away giving you the concept. Number 1 is intro to linear regression. Intro to linear regression, because that topic itself finds its application. Regression, that topic itself finds its application. It's part of reading 1 only, so no point. And second thing that you will require knowledge of is hypothesis testing. So in case, again I'm repeating, there is a student who had surpassed hypothesis and still managed to clear level 1 exam, I would strongly suggest you will have access to our videos for hypothesis testing level 1 videos. You can just go through it again, or if you don't want to go through the videos, you can read the content and then also, but you should have sufficient knowledge with regards to hypothesis testing. Okay, so and similarly whatever concepts will be there for different subjects, I will keep on telling you. Okay, this is part number 1, application part, and second is the broad layout, in which the format in which we'll be studying is first completing the reading, and you also will be are suggested to complete the reading along with me, and then we will try to solve the Vinet based question together. Okay, so that is something which will be there. Okay, any doubt, any question before I start off with the content part today? And yes, the third part is, do watch my orientation video for level 2. It will be highly helpful. Any question, any doubt you want to ask? No question?
Mohit, how would be the classes be scheduled? Is it weekend or how it is gonna be?
So the classes are on Monday and Friday from 7 to 10.
Okay.
Okay. Okay. Now, let's start off with the concept part. Multiple regression. In reading 1 of Introduction to Linear Regression, you would have come across, and we have discussed in great detail, what linear regression is. And the primary difference, or the equation that we took was of the regression, the equation that we took was y is equal to y is equal to b0 plus b1 into x1 plus ei. What does it indicate? It indicates that there is a dependent variable. There is a dependent variable or explained variable, dependent variable or explained variable, and there is a independent variable, or explanatory variable. Okay, so this variable is being explained, and this variable is explaining the dependent variable, the movements or variation in the dependent variable. For example, share price of say for example a cardinal health, share price of cardinal health, and the second is the you can say the aging population of America. So these are related. If the population is aging, then there will be more demand for pharmaceuticals, and if the population is young, relatively there will be less demand for pharmaceuticals. I have taken a hypothetical example. So the two concepts that we are, so this movement in share price of cardinal health is a dependent variable, and the one that it is explaining it is the independent variable, which is the demographics of US, or the demographics of the world, changing demographics of the world. Okay, the problem or the point over here is that in Introduction to Linear Regression, our restriction was that we only assumed that there can be only one factor which will affect the dependent variable. So the limitation that we put in reading 1 was that there will be only one factor which will be a dependent variable, and rest all other factors will be there will be one factor which will only explain, and whatever the balance is, it will go into the error term or the unexplained portion. Okay, now, and we all know that in real life, there any factor in this world generally is not explained by one factor, but there are n number of factors which affect the movement in the share price, and this will result in changing the format of the equation to y is equal to b0 plus b1 into x1 plus b2 into x2 plus bn n, or whatever you want to say, bk into xk. Why I have used k is something you will get to know, plus ei. That means instead of using one independent variable, we will be using multiple variables, multiple factors or multiple variables. Okay, b1, b2 and bn, whatever the number of factors are which are going to affect it, we will be using that. Okay, this is the situation when you change the equation to this format. It is called multiple regression. Multiple regression. Okay, this is called multiple regression. So the concepts primarily are going to be same. The knowledge primarily is going to be same. The t test, the f test, each and everything is primarily going to be same. The predicted value, all these things are primarily going to be same. The only difference is that here we restricted ourselves to only one factor which will explain the dependent variable, and here we are using multiple factors. Multiple factors, and this multiple factors is nothing but linear, or sorry, multiple regression. It is multiple regression. Now you would be thinking that this is going to be a plain vanilla stuff, because if this was here, it was one factor, now here will be two factor or three factor that you will get in exam. But when you start introducing more number of factors, the entire landscape of the analysis changes. If you are thinking, or majority, when I was also student who listened it for the first time, I thought that okay, the logic over here is that suppose if y is equal to 6 plus 0.5 into, say for example, GDP. Say for example, GDP is a factor. Okay, so GDP, this was my first equation. Then if or instead of y, let me put it as share price of cardinal health. Okay, let's continue with that example. So if I introduce another variable, then it would be 6 plus 0.5 GDP plus say for example 0.2 into interest rate. I'm just taking a random example. Okay, just understand the perspective. That would be the equation. If you are thinking in that manner, this is absolutely wrong. This is absolutely wrong, because you have to recognize one fact. The fact is that when you add another variable, which is interest rate, then interest rate is helping us to explain the share price of cardinal health, the movement in share price of cardinal health. However, interest rate is also linked to the GDP, which is the first factor, and there will be some correlation between interest rate and GDP as well. So when an interest rate increases by 1, then definitely the share price suppose increase by 0.2, but the GDP will also be affected, because interest rate and GDP are not unlinked or uncorrelated, they are also correlated, and that is why it will result in change in GDP as well parallelly, which will again affect the share price. Are you getting my point? What I'm trying to say, that when you are adding more factors, then you cannot think of it in that way that okay, 6 plus 0.5 GDP, it was there, now it will be 6 plus 0.5 GDP plus 0.2 interest rate, just adding that factor. No, that is not going to work, because this is not a linear maths going on. Here interest rate is affecting the share price, but interest rate is also related with the GDP. That is the new factor that you are adding is also related to the previous factor that existed, and since that existence that is related, so there will be some correlation which will again affect the impact of the have an impact on the equation. And that is why when a new factor is getting added, the equation will entirely be changed, and it will be somewhat like, it will look somewhat like supposedly 4 plus 0.8 GDP plus 0.3 interest rate, somewhat like this. That means the broadscape or the landscape of the equation has entirely changed. Okay, I hope you are understanding what I am trying to say. Why this is happening? that y element is very, very important. Why is it happening? It is happening because of only one reason, that is the new factor that you are adding. That new factor is also related to the first factor that was there, or the first factors that were there. And when you add that factor, then movement in interest rate will affect the share price, but movement in interest rate will also affect GDP, which will again affect the share price of the company. So to account for that collinearity, there will be a concept which we'll discuss, which is called multi-collinearity. To account for that collinearity, we have to recalculate the entire broadscape or the coefficient of the previous factors also, as well as the intercept also. And this is what is called the effect of adding a new variable to the equation. Okay, is this clear?
Yes.
The second aspect which I want you to cover, all these are basic discussions going on. Now we will move into LOS wise format also, but now I'm just laying the foundation over here. The second aspect which I want you to understand is how many factors are there in this equation. Let's take this example. How many factors are there?
Two
When you say
factors.
factors, so like
Factors, GDP and
Like
interest rate, correct?
GDP and interest rate, yeah.
Which factor is more important?
Wouldn't they both be more important? Maybe the interest rate.
Interest rate. And how do you concluded that?
I'm gonna just take a stab. Maybe because GDP is somewhat lagging, like interest rate is real time, so it's gonna. I don't know. I'm just trying to rationalize out loud. When I think about the
Okay.
markets opening and all, like it fluctuates on a daily basis. So I would imagine it has the bigger impact because it can happen in real time.
That's good that you're thinking in that manner, which is a required manner. But I would want you to think from a layman perspective only once, to understand what I'm trying to say. If I would have asked, from a layman perspective, I'm saying, if I would have asked which factor is more important over here, anyone would have said that Mohit, here the coefficient of GDP is 0.8 and coefficient of interest rate is 0.3. What does the coefficient mean? What is the interpretation? When GDP rises by 1 unit, then the share price increase is expected to increase by $0.8. When GDP rises by 1 unit, say for example 1%, the share price is expected to increase by $0.8. Okay, this was the interpretation. And here, since when interest rate rises by 1%, the share price is expected to change only by $0.3, that is increase by $0.3. So from layman perspective, someone would have said this factor is more important. From regression or from Quants perspective, which factor will be considered to be more important is the factor which is explaining majority of the variation in the share price or the dependent variable. Again, I'm repeating, the factor from Quants perspective will be considered to be important or significant is something which is explaining a major portion of the variation of the dependent variable. By looking at the coefficient value, someone can easily say that this factor is more important. However, this is absolutely a wrong approach. The coefficient is just an indicator or just a number. It does not reflect the statistical significance of the factor. Be very, very clear. Okay, so if the coefficient of two factors are there, coefficient of GDP is high, coefficient of interest rate is low, it does not mean that GDP has higher explanatory power compared to interest rate. No, it may so happen that GDP, which has a highest coefficient, may be proved to be statistically insignificant. statistically insignificant. We will learn today how to perform those tests, t-test, f-test, coefficient testing, etc. It may prove to be statistically insignificant compared to interest rate. So this is another, what you can say, the myth or the common error that student may make or presume is that the one factor with the higher coefficient value will have the higher explanatory power. No, that's absolutely wrong. It will not be. Okay. Yeah. Just one. Yeah. One more thing. Here, can you give an interpretation to me? Here, what is the interpretation of 0.5? How do you interpret the 0.5 in that language format? I want you to do it in that language format. When GDP rises by 1 unit, what will happen?
Share price will rise by 0.5.
$0.5, correct. Okay. Here, if I make a statement, when GDP rises by 1 unit, say for example 1%, the share price is expected to rise by $0.8. Am I correct? Or I am missing on any part? Is this statement complete? Which part?
No, it's not complete because you're not considering the other independent variable.
Right. That is interest rate. So here the tone would change that when GDP rises by 1% or 1 unit, the share price is expected to increase by $0.8, holding interest rate constant. Assuming that interest rate is constant, if the GDP rises by 1 unit, then the share price is expected to rise by $0.8. This will be the tone, or this will be the language that we will use in multiple regression, because the only factor is not GDP over here. Here there are multiple factors in which one is GDP. So if you have to draw the correlation of GDP only, then you will have to assume that other factors are at ceteris paribus or are at constant. Okay, so this is the thing that also you will have to understand. So what are the broad perspectives that we have discussed? Or I think there are 3 concepts that we have discussed. What were the 3 concepts? Number 1, can you help me recall what were the 3 concepts?
So in multiple regression, there are multiple factors affecting the dependent variable.
Number 1.
Second, adding one more factor to that equation will not only affect the dependent variable, but would also affect the independent variable, and this brings the multicollinearity into.
Right. Okay. Okay.
And if you wish to see the effect of only one variable, then you need to hold the other variable constant.
Correct. And 4th is coefficient is not a determining factor. The value of coefficient is not an indicating factor. That's correct. Thank you. Number 1, value of coefficient tells us nothing about the explanatory power of dependent variable of the independent variable. Number 2, yeah, when we add a new variable, it will also impact the intercept and the coefficient value of intercept and coefficient value of the original equation because of correlation between independent variables. Okay, and the third is, what was the third one? Yeah, holding other constant. That was it, right? Holding other constant. So we have to assume that when GDP in our example rises by 1 unit, then share price of Cardinal Health is expected to increase by $0.8. Okay, holding interest rate constant. This is what we have done, is basically the crux. Okay. Okay, now what I am doing is I am giving you a general equation in the way it is given in your CFA. Okay, just 1 second. And if you want, you can write all these, but otherwise PDF will also be uploaded along with the video in the drive. Okay, so you will have access to the PDF as well. General equation. The CFA format is yi is equal to b0 plus b1 into x1 plus b2 into x2. I have simplified a bit, not significantly, majorly it's same, but I have done a level of simple simplification. bk into bkth term into xkth term, yk and y naught n is something which you will get to know, plus ei. This is the general equation that is used in CFA, okay, of a multiple regression, where b0 is the intercept. We know the nomenclature, but I'm still explaining. b0 is the intercept, b1 is the coefficient, x1 is the factor 1, independent variable 1, variable 1, okay, and ei is the unexplained portion, error term or unexplained portion. What do you mean by unexplained portion? The variation in dependent variable, the portion of variation in dependent variable which is not getting explained by the equation. So the entire equation over here, just 1 second, the entire equation over here is this portion which reflects my explanatory power. This reflects my explanatory power. I am using the term ESS, explained sum of square, or explanatory power from the equation, and this portion whatever is left is the unexplanatory power or sum of square errors. Sum of square errors. Okay, and this is the TSS, the total sum of square. These terms should not be new because we have discussed it in reading 1. So this is not a new nomenclature that I am saying out over here. Okay, you should be verbant with that. Verbant, you should be habituated, or you should have known this particular part. Okay, this is TSS, total sum of square. This is sum of square error. So in layman terms, if I am to say, suppose the share price variation is 10. Variation is 10. I'm not specifying a unit over here. Then if the model is able to explain 8, the remaining, which is the unexplained portion of the variation, is 2. So that means our model's ability to explain the variation is 80%. 80% of the movements or 80% of the variation in the dependent variable is being explained by our model. Model means, explained means including all the factors, all the independent variables that are there in the model, and balance, which is 20%, is not being explained by our model. This is how it is structured, or it means. Okay.
Hey Mohit, is TSS the same as SST and then ESS?
Yeah, that is same as SST. So there are some synonyms. Thank you for that. TSS, total sum of square, or SST, sum of square totals. That is same. ESS is explained sum of square, or it is RSS, regression sum of square.
What does the CFAI use?
CFAI use this RSS and SST. Actually, this TSS and ESS is also used, but it is more predominantly used in, you can say, FRM content. More predominantly, but both are synonyms and both are applicable everywhere. Okay, so you have to know both TSS and SST, and ESS and RSS. Okay, RSS is also there, and here is SSE or ESS, error sum of square. Or sorry, or not S. This is SSE or RSS. This RSS and this RSS are different. This is regression sum of square, and this is residual sum of square. Okay, but don't be confused. You will be given full name, full nomenclature in exam. So don't be confused about that. Yeah. One second. Yeah. Okay. Now the result of the procedure. Okay. Now with the help of this equation, how this equation is used in real life. The simple application of this equation is, just one second. Just one second. Yeah. The simple application of this equation is to predict the value of the dependent variable. In real life, why are models created? The models are created to predict the value of the dependent variable, or of the dependent variable using the forecasted value of the independent variable. For example, suppose, going back to my original equation, this one, share price of Cardinal Health is equal to 4 plus 0.8 GDP plus 0.3 interest rate. Okay. Now, why as an analyst I will frame this equation? I am an analyst trying to invest in Cardinal Health shares. I am an analyst trying to invest in Cardinal Health shares. Okay, and that is why I have developed this model. Suppose hypothesis testing is done, my model is 100% perfect. Now what I will do is, to calculate the forecasted value of the share price of Cardinal Health, what I will do is I will take the forecast the value of GDP and forecast the interest rate. Okay, suppose the value of GDP, I'm taking a hypothetical example. Suppose the value of GDP is it is getting measured in trillions. Okay, so it's US GDP is getting measured in trillions. Supposedly it's $100 trillion. Supposedly it's $100 trillion, and supposedly the interest rate is 4%. Okay, now these are the forecasted value. These are the forecasted value. Okay, now the expected share price, how I will use that is 4 plus 100 into 8, that is 80, plus 4 into 0.3 is 1.2, and 84, 85.2. So the expected share price of Cardinal Health should be $85.2. This is the what my forecast is according to the model. This is why the model is actually prepared or is actually used to calculate the predicted value or forecasted value of the dependent variable. Okay, now when you do that, then from nomenclature perspective, I am saying in CFAI, from nomenclature perspective, there is a hat sign that is included above the equation. Okay, yi hat is equal to b0 hat plus b1 hat into x1 plus b2 hat into x2 plus bk hat into xk plus, and the error term would go away, would go away because you are actually trying to predict. When you are trying to predict, this happens. The hat sign comes when you are trying to predict. When you are trying to predict. Okay. Now, why this error term is not there? That is the question. Why this error term is not there? Because when you use this particular equation in real life, suppose the equation is developed, my hypothesis testing is done, all my factors are good, my F test is done, everything is going good, and my equation is super good. Suppose according to hypothesis, my equation is super good. It is able to explain majority of the variable, 80% of the variation, something like that. Okay. However, when you put to test in real life, then you you do the reality check. When you forecast all the values of the independent variable, you get the forecasted value of the dependent variable. Okay, when you get the forecasted value of the dependent variable, we call it as the predicted value. What do we call it? We call it as the predicted value. Yi hat, that is the value that you get from the equation, is called the predicted value. Predicted value. And the actual yi that you will get is called the observed value. Observed value. Observed value. Okay. Again, I'm repeating. When you use all the forecast and you get the value of yi, that is called the predicted value, and what we get from the equation, that is yi value, the real value of the dependent variable, and that is called the observed value. And the difference between the two, that is yi minus yi hat, is called the error term or the variation which is not being explained by the model. Error term or the variation which is not being explained by the model. Okay, so this is how the error term in real life is calculated, that how much portion. So supposedly you would be thinking that how we will calculate the error term. So this is how it is calculated, that you forecasted something. Suppose the share price of Cardinal Health you forecasted to be $85.2, and in real life the share price comes out to be $87. Then the difference of $1.8 is the error term. Difference of $1.8 is the error term. That is, this particular variation was not being able to explained by the model. Okay. Any question, any doubt till here? No question, no doubts. Okay. Just one thing. Let me go back. Here, whatever we are doing, this will be our part one, which is what we are doing. Part one, that is introduction, or you can say basic knowledge. Basic knowledge. Okay. Because the entire reading we will divide into multiple parts. Okay. Part one is basic knowledge. Part two will be heteroscedasticity, or dealing with the regression, or doing all the tests. Part three will be heteroscedasticity. Part four will be multicollinearity. Part five will be model misspecifications, and part six will be residuals. So this is how broadly we will divide our entire reading into various parts. Okay. Now this is what we are doing is part one. Till now, whatever we have done, that is part one. That is basic knowledge. Okay. If this be clear, then let's start off with part two. Part two. Performing the tests. Performing the tests. And here only we will also start with our first LOS, which is LOS A. Okay, I'll not write it. I'm reading out to you what LOS is saying. Formulate a multiple regression equation to describe the relation between dependent variable and several independent variables, and determine the statistical significance of each independent variable. Okay, so first it is saying formulate a equation. We have already done the equation. Then it is saying that describe the relation between dependent and several independent. We have already done that. The only portion which we are not able to cover till now is test the statistical significance of each independent variable. Okay. Let's continue with a standard example. So I will be writing this example for you. 1 second. Standard example. Okay. Repeatedly, we will be using this example throughout our discussion. EG10 is equal to B0 plus B1 into PR plus B2 into YCS plus EI. This is our standard equation, where EG10 reflects what? EG10 reflects the 10 years earnings growth in S&P 500. Okay. PR is equal to the payout ratio. Payout ratio of constituent securities. And YCS is the yield curve slope. Yield curve slope. Okay. These are the three equations. This is the standard equation. Okay. You are also supplied with the required data, and the required data is coefficient Okay, let me write it in the second page. Required data is coefficient and standard error. Standard error. Okay. Intercept minus 11.6%, 1.657%. PR, the coefficient is 0.25 and 0.032. Standard error. YCS, the coefficient is 0.14 and that is 0.280. Okay. Here we are doing LOS A plus B plus C. Just 1 second. Yes, A plus B plus C plus D. All the 4 LOS is getting covered in our discussion here. Okay. A plus B plus C plus D. This is our standard equation. Now, again, I hope you know that, but still I'm telling. Coefficient means the value that is there that you use ahead of that independent term. So suppose if this equation is there and the format is laid out to you, can you frame a numerical equation with numbers? Can you rephrase this equation with numbers using this data? Is it possible? Can you rephrase this equation with numbers?
Yes, because you have the intercept and the coefficients.
Right. So how will it look like? E.g. 10 is equal to
negative 11.6%.
11.6% plus
0.25 PR.
Yes, 0.25 PR plus
0.14
YCS.
YC.
0.14 YCS plus EI. Yeah, this is how it will look like. Thank you. This is how coefficient is getting utilized. Okay. Now, what is the interpretation of the intercept? What is the interpretation of the intercept? The interpretation of the intercept is same as it was there in the linear regression. It is that if the terms, all the independent variables are zero, if all the independent variables are zero, then the dependent variable, the minimum value of the dependent variable or the value of the dependent variable will be minus 11.6%. That means if the payout ratio is zero, if the yield curve interest rate is zero, then also the earnings growth will be there and it will be negative 11.6% according to this equation. This is the meaning of intercept. If we go back to my original equation that we have done, that we took hypothetical equation, in that case it will be 0 at both sides and the share price of the cardinal health will be 4. Correct? The share price of cardinal health will be 4. That means the minimum value or the value of share price, in case the GDP is 0, the interest rate is 0, then also it will not be 0. It will have some value which is 4. This is the interpretation of the what do you say? Interpretation of the intercept. Okay. Now interpreting the slope we have already done. That means if PR increases by 1, that is payout ratio increases by 1% or whatever it is, 1, unit, then the earnings growth is expected to increase by 0.25 units. If YCS increases by 1%, then the earnings growth is expected to increase by 0.14 unit. Okay.
But you also do you have to add in, given that YCS is constant?
We have to add in that remains the same, that if PR increases, then this increases, assuming YCS is constant, or same goes with YCS. If YCS increases by 1 unit, then EG is increasing by 0.14%, assuming that the PR is constant. Okay, that is why they are called partial slope coefficients. They are called partial slope coefficient. They are not full coefficients. Because what do you mean by full coefficient? The one that I presented it over here in this equation, this was a full coefficient, because when GDP rises by 1 unit, then the share price directly increases by 0.5. This is a full coefficient. There is no conditionality over here, but here there is a conditionality that this will happen assuming that the other factor are constant. So that is why they are called partial coefficients. They are not called the full coefficients.
Hey, Mohit, if you have a multiple regression, how would it look like in a scatter plot? Because the linear one, you just had one independent. How would 2 look? The same?
Because in linear, we presented it with the one factor only. Okay. If you have multiple factor, then also it will look, because you scatter plot is drawn using one factor, one particular factor. So if you draw it with the one particular factor, it will be same, like separately if you draw it. But this question will be answered in more detail when we will move into heteroscedasticity, that particular part, because there we will have to draw the scatter plot to understand where the model is or is not heteroscedastic in nature. So all those concepts will come basically when we'll discuss that particular part. Okay, this is all what I have already explained you. Okay, but we have already discussed that part. Now coming to the hypothesis testing of regression coefficients. Just 1 second. Coming to the hypothesis testing of regression coefficients. All that hypothesis testing for regression coefficients. Just to recall, there were 3 ways to perform a hypothesis testing. Number 1 was confidence interval method. Number 2 was test statistic method, and number 3 was p-value method. All the 3 will result in same answer or same conclusion. Okay, broadly if you say, there were 2, because confidence interval and test statistic method are largely same. It's just interchanging the way you go to the same conclusion. So if you speak in broad terms, there were 2 approaches: test statistic method and p-value method. Okay, both knowledge of both will be required over here now, because now from here on we will be using all those tables, which is the T table, the F table, etc. that was there, and we will be calculating the test statistic, and we will be testing whether the coefficients are significant or not. Okay, number 1, what is the purpose of the testing over here? First you have to understand the purpose of the testing over here is that we are trying to test whether the coefficients are statistically significant or the coefficients are statistically insignificant. For example, as an analyst, I was trying to calculate the earnings growth, 10 years earnings growth of S&P 500. Okay. To conclude these two factors, payout ratio and the YCS, do you think that it would have been so simple for me as an analyst who just started it for the first time, that I just go into the market, I look at all the variables and I say, okay, payout ratio, payout ratio and YCS are the only two factors out of the 100 factors that is available. Would it had been that easy, or it would have required some efforts from my side, some analysis from my side?
More analysis?
More analysis. That means these were not the only two factors that was available. There were more other factors that was available, out of which I have selected these two factors. Okay. That means I have also rejected other factors. How to reject and how to accept, is the factor important or is the factor not important to explain the dependent variable, is something which we are going to learn now. So when in real life you will be creating your own equation, or when in real life you will be trying to create a model for yourself, then you will also be faced with the problem that there are multiple coefficients or multiple factors. Which one to include and which one not to include is something which we are trying to test over here on an individual basis. Very important. On an individual factor basis, not on a overall model basis, because that requires a separate test, which we will also learn following this. Here our purpose primarily over here is to learn the testing on a individual factor basis, individual factor. So that is what we are trying to learn. Okay. To test the individual factor, whenever you are to perform an individual factor test, there is a simpler way, that number one, you will use the t-test. You will use the t-test, which requires one tail or two tail. Again, that knowledge is same. If it is equal to sign, then it is two tail. If it is does not equal to sign, then it is a one tail test. Okay. And the second thing that is there is the t test is there, and the second thing that is there is that the test would be to conclude that whether it is statistically significant or whether it is statistically insignificant. The test would be that whether the slope is equal to 0 or whether the slope is not equal to 0. As a researcher, what will I want? Whether my factor to fail or whether my factor not to fail. As a researcher who has created this model, what do I want? My factor not to fail?
Yes, not to fail.
Not to fail. And if I want my factor not to fail, that means I will have to prove that the coefficient of the factor is not equal to 0. Because once I prove that the coefficient of the factor is not equal to 0, that means this factor has some impact or some explanatory power in the movement of the dependent variable. Think. When a factor will be proved to be statistically insignificant, or it will not have an impact, when my coefficient is 0. Because if my coefficient is 0, any change in the factor will not result in any change in the dependent variable. If that be the case, why are you including it over here? There is no point of including the factor over here, right? So my testing point would be, I am trying to test what? I am trying to test whether my factor is statistically significant or whether my factor is statistically not significant. That is what I am trying to test. Okay. If I am trying to test that thing, I will have to first conclude that whether the coefficient is non-zero. Okay. So as a researcher, I would want my factor to be proved as what you say, statistically significant. So I will want it to be not equal to 0. Okay. If researcher says not equal to 0, then the null hypothesis will say the opposite. Null hypothesis will be equal to 0, and the testing will be performed basis equal to 0, and then we will have to conclude whether we accept whether we reject null or we fail to reject null. Okay, so this is how we are going to do it. Okay, number 1. Just 1 second, let me write it. It would be applicability of the test when you are trying to test the individual when you are trying to test the individual coefficients and not the model as a whole. Okay. Then the next is what type of test we'll be using. T-test. Okay, it can be one tail or two tail. Okay, the third is what type of test is done. What was the third thing that we discussed? Yes, it was will be the criteria of the test. What will be the criteria of the test? The criteria of the test will be whether is equal to 0 slope, sorry, as a researcher dependent factor to be non-zero. Hence, hence, 1 second. Here I am writing. Hence, HA will be equal to B1. Yeah, BJ. Suppose that is the slope. HA will be slope does not equal to 0, and therefore H0 will be that BJ equals to 0. That will be the testing of statistical significance. Okay. If this be the testing of statistical significance, now we can perform the test. The T test, what is the T statistic value? How do you calculate that? The T statistic value is very simple. T statistic is equal to estimated regression coefficient, okay, minus hypothesized value divided by standard error, coefficient standard error, coefficient standard error. So again, this t-test is something which we have already performed, which this is not a new factor. This is something which we have already known. Okay. So you are supposed to know this particular equation. Now using this particular test, you will get a t value. Then you will again put it and check it with the t critical, which is from the table. What is the value you're getting? This is t statistic, and at a certain confidence level, you will get the t statistic, t critical value. Okay. Now you can take a decision whether to accept null, whether we accept null or we fail. Whether we reject null or we fail to reject null. Okay. Do remember very one thing which is now different from what we have learned in the linear regression, and the thing is that degrees of freedom as per t-test will be equal to n minus k minus 1. And here is what this k I was continuously referring to, that k you will come to know why we are using k, why we are not using n, etc. That nomenclature now you understand. N minus 1, the original linear equation. In the linear equation, the degrees of freedom that we used was n minus 1. N minus 1, where 1 is the intercept term. 1 is what? 1 is the intercept term. Okay. Because you are using intercept, you are losing 1 degree of freedom. Okay. Here, the degree of freedom that we lose is k. K represents the number of independent factors that we have. K represents the number of independent factors that we have. Okay. So if suppose we have 2 independent factor, then k will be 2. If we have 3 independent factor, the k will be 3. What is it trying to say, or what is the cost that it is trying to levy? You will understand this particular thing as we proceed ahead into the concepts of multicollinearity, heteroscedasticity, and etc. That as an analyst, if this concept is clear to me, that this entire model together reflects the explanatory power of the equation, and this particular portion reflects the unexplained portion. As an analyst, what will you target? To have a higher explanatory power or lower? Higher. And if you have higher explanatory power as an analyst, suppose if you have higher explanatory power, to increase your explanatory power, what you will try to do is you will try to include any number of factor. Suppose there are 2 factors and together it explains suppose 70%. Let's include one more which explains only 1 more percent. But what is the harm? Are you getting the thought process that will be there of analyst? The thought process will be, let's increase the number of factors and let's increase the explained sum of square, because I want to increase the explanatory power of my model, and I don't care whether it includes 10 factors or 20 factors. I'm sorry, whether it includes 10 factors or 20 factors or 30 factors. That would be somewhere or the other the concept that would go in the mind of the analyst. Correct? To put a cost to that particular thing, just 1 second, I dropped my pen. Okay. To put a cost to that particular thing, the concept of n minus k minus 1 is introduced. This k represents the number of factors that you are using. So if you are using more number of factors, you will lose your degrees of freedom. If you lose your degrees of freedom, hypothesis says that your t-test will be more difficult to pass. Your t-test will be more difficult to pass, and overall your model may altogether be failed by a f statistic that we will understand. So as an analyst, it cannot be that you can increase the number of factors by 10, 15, 20 and okay, let's increase the explanatory power to 90%. Oh, my model is able to explain 90% of the variable. That's so good. But the point over here that you are missing is that who is going to forecast 20 variables? What was the purpose of creating the model? The purpose of creating the model is to forecast that particular dependent variable, to find the share price of the company, to find the earnings growth of S&P 500. and it will be more easy and more accurate to forecast the S&P 500 value or the share price using the model if the number of independent variables are lesser, not very much. Because if you have 20 independent variables, you have to do 20 forecast of 20 odd n number of factors, then you will get one factor. Can you accurately forecast and track the 20 factors? No, it is not possible. It is not possible for anyone. So that is why the model is designed in such a manner, the testing is designed in such a manner that it discourages an analyst. It discourages an analyst who brings lot or to create a very lengthy equation with lot of variable factors. It encourages an analyst to think before adding that particular factor, that is it making economic sense to add that factor. That means do the cost benefit analysis. If I add the factor, then by what percentage it will increase my explanatory power versus how I will lose my degree of freedom, how my model will be altogether impacted, and how difficult it will be for me to keep on tracking that particular factor, additional factor. Do that cost benefit analysis and feasibility, and then only add the factor if the explanatory power is very good. If the explanatory power of the factor is small, then don't try to or don't attempt to add the factor, increase the number of factors, because a lengthy equation is not liked by anyone in real world. Are you getting what I'm trying to say? Where the concern was and why this framing is done?
What is an appropriate error value?
Appropriate
Error value? Like
there is no appropriate error value. It depends on the situation, because the items that we can test are very different. In one area I can test exotic option where the data is very rarely found and the error may be 30%, 40% error may also be workable. And one area would be I am predicting a daily or traded share where maybe the predicted the error value would be somewhere around 20 or 10 error value would also be considered to be high. So the point over here is that there is no right or wrong, or there is no specified thing that this is the right appropriate error, or this is. It will purely be a judgment of the analyst and the level of confidence that he reflects in the model. And it depends on the item set that you are dealing with. What is your dependent variable that you are dealing with? Okay. Any other question? Are you able to get the gist of why I have focused so much on K? Because this knowledge, any which ways, you will discuss when we will proceed ahead. So I wanted to give, because now we are only discussing K, so I wanted to give it ahead only, that why K is so important, and a real life perspective of the entire thing, that when you will go and do this thing in real life, if you are a quants analyst or something like that, in that situation you have to keep all these things in mind. Okay, is it clear? Any doubt, any confusion?
Just quickly, the t-test is for each independent variable coefficient. So the t-test is for, let's say, just the PR coefficient minus the hypothesis value. Right. And you do that for each independent coefficient. Right,
exactly. So for each independent coefficient separately when we are testing. So I only want to test PR, I only want to test the YCS, I only want to test the intercept, then I will use the t-test. When I want to test the model together, the entire model together, then we will use the f-test. That knowledge will come as we complete this particular portion.
Last question. You said an analyst may want to just put in or use so many independent variables, and the cost benefit would not make sense. What does that mean when you're saying cost?
Right. What I'm trying to say is the cost is the K over here. The degrees of freedom that you're losing. See, this degrees of freedom, what does it indicate? First, as you decrease your degrees of freedom, if suppose suppose I had 46 observations over here. Standard example, I've not written over here, just 1 second. Using 46 observations, or let me write it over here. Using 46 observations we get, okay, using 46 observations I got this particular data. Okay, now if I am to calculate the degrees of freedom, 46 is my n, my k is 2 PR and YCS, two factors, two independent variable, and -1 is the for intercept which we normally do. So what will be my degrees of freedom? 43. Okay, if 43 is my degrees of freedom, then if suppose, just 1 second, let's open a T table. Open a T table once. Okay, open a T table once. It would be there in your appendix. Has everyone opened the T table? Just confirm me.
Yes.
Okay. Now there is no 40 over here. Let's look at two tail and let's look at 5%. Two tail 5%. I'm taking a hypothetical example. Okay, I'm trying to explain the impact. Two tail 5%. Okay, 0.05. So below 0.05 in front of 40. Let's assume 40. Okay, because 43 and 40 they are near. So let's assume 40. What does the value comes? What is the value you're getting?
2.021.
2.021. Is everybody getting 2.021?
Yes.
Yes, everybody with me? Now 2.021 is the value. Okay, what does this 2.02 in a two-tail test signify? That if the hypothesized value is between -2.02 and +2.02, then we will fail to reject null. If it is beyond this, then we will reject null. Suppose if I draw that particular diagram, it would look something like that: -2.02 and +2.02. This area is fail to reject null, and this area is reject null. Correct? Now suppose instead of 2 factors we are using 12 factors. Instead of 2 factors we are using 12 factors. 12. Okay, there are 10 more factors. What will be the new degrees of freedom? What will be the new
35.
degrees of freedom? How much?
35.
35. How does it come to 35?
You said K is 10?
K is 12.
Oh, K is 12. Oh, okay. Then 33.
33, correct? 33. We don't have 33 over here. Now check the value for 33. We don't have 33, we have 30. So 30, the value is
2.042. That's not too far.
That's not too far. But as the value keeps on decreasing, because t-test, when, again recall central limit theorem, when generally a t-test is performed, when the number of observations or the sample size is smaller. When the sample size is very large, then we preferably use a z-test compared to a t-test, if you recall the central limit theorem. Okay, so here what this statistics is trying to signify is that as you keep on reducing the degrees of freedom, the band of fail to reject will keep on increasing. Okay, this was very close because we have already crossed the central limit theorem point of 30, and beyond 30 the t-test approaches the z-test, if you recall that. Suppose the impact will be more felt when you will take data from a lower numbers or a lower order. Okay, suppose 20. If we take 20 as the degrees of freedom original, 20 as the degrees of freedom original, what was the degrees of freedom that we have? 2.086. So the t value that was there was 2.086. Again, the order is between this range you will fail to reject, and beyond this you will reject. Okay, now if suppose you decrease it to, say for example, you decrease it to 10 or you decrease it to 15, then you will see that it is 2.131. Again, that change is being felt, the change is there. So the area where we fail to reject null is increasing. This is the first aspect which discourages the analyst to take more number of factors. Okay, the second aspect and more practical aspect is that as you keep on increasing the number of factors, it is easy to track 2 factors, but it will be difficult to track 12 factors in real life. As an analyst, you won't be able to, because when you will track 12 factors, how you will forecast the share price? You will have to first forecast the values of all the 12 factors, and then you will have to use that forecasted value to forecast the value of the S&P 500 or the share price. So forecasting the value of 12 factors is relatively difficult because you have to go into granular details of each factor, or maybe you have an equation, 12 different linear equations for those factors, and you will have to use the equation to forecast that particular factors, and again you will have to come back using that data to forecast your dependent variable. At every factor that you forecast, there is another analogy, or advanced statistics says at every factor forecasted value that you are using, you have to also plug in the confidence level of the forecasted value at factor level. So for PR, suppose I am using a factor of 0. Suppose I am using a factor of 2. The value forecasted value is 2. That with 2, I will have to say how much confident I am with regards to the value of 2. Suppose 95%. And YCS, suppose I use 4. Then again I have to say how much confident I am. Suppose 90%. Then this 90 and 95%, a combination of it will be created to create that the predicted value is there, but how much confidence we have on the predicted value. That level of confidence will determine the level or quantity of trade that you can take on that particular equation, and that quantity of trade will automatically determine the level of profit that you are able to earn.
Aren't these all just computer programs that you can just put in
Yeah.
and it isn't as complicated?
These are computer programs, but the model has to be developed by the analyst. Computer can work on the model, but the forecasted value, who will give that forecasted value? Who will give that what should be the price of crude oil, especially in the mid of Russia-Ukraine crisis that we all are seeing now? It has shot up from $100 to 118, and where it will go, whether the crisis will be more intense or the crisis will be relaxed, that forecasting element computer cannot do. That is why analysts and humans are required.
Okay, so that part is the fundamental side that an analyst does, and then once he gets that value, he plugs it in, but he has to get that value first, and it could be subjective.
It is highly subjective. It is definitely subjective. You may believe that it will become more intense, and I may believe that it will become relaxed from here on. So our perspective may change entirely. Okay. So I hope you got the logic of n minus k minus 1. Okay. Now we are performing the test, actually performing the test. Using the standard data, calculate the statistical significance of each independent variable and intercept. Okay. So calculate. You have the data with you. This is the data that is there. Just 1 second. Let me clean it. Okay. So perform the test and check whether the coefficient is statistically different from 0 or not. So how you will go about it? Let's assume we start for a PR or intercept. Let's assume we start for intercept. Okay. So for the intercept, 1 second, solution. Intercept, and we are testing at 5% significance or 10% significance. We are testing at, just 1 second, test at 10% significance level. Okay. For intercept, how we will go about it? So the intercept value is the test. First we'll calculate the degrees of freedom. So the degrees of freedom is 46 minus 2 minus 1, which is 43. Okay. And then we will calculate the T critical value. The T critical value at 5%. And what test is it? Is it a 2-tail or is it a 1-tail test? If you are testing statistical significance, then I have clearly stated what it will be. It will be HA will be not equal to 0 and H0 will be equal to 0. That means it is a 2-tail or a 1-tail? It is a 2-tail test because it is equal to sign.
Oh.
If it would have been a greater than sign or a less than sign, it would have been a 1-tail test. But since it is a equal to sign, it is a 2-tail test. Okay. So this is a 2-tail test. 2-tail test. 2-tail value is equal to how much value you are getting? T critical at 5%. So look at the T table. Look at the T table. Okay. At the left hand side, degrees of freedom, you should look at 43, but 43 is not there. 40 is there. Okay. So check for 40 only. 40 in and 0.05 2-tail. 0.05 2-tail 40. What is the value you are getting?
2.021.
2.021. Let's assume it to be 2.022. Let's assume, because it is 43 and that was 40. So there is no science about it. We are taking an approximation. Just an approximation. It doesn't matter. It is immaterial. If you take even 2.021, your answer will not change. Okay. So let's take it 2.022. Let's assume that. Okay. So in simplification perspective, what will be the order over here now? The order will be that this will be the equation. Here it is minus 2.022 and here it is plus 2.022. This region, if the T statistic value is between this, then we fail to reject. And if it is here, then we reject null. Correct? Are you with me till here?
Yes.
Okay. Now the T statistic value. Calculate the T statistic value. What it will it be? estimated regression coefficient, that means our coefficient value that we are actually getting. Our coefficient value is minus 11.6. So minus 11.6 minus hypothesized value. What is the value we are hypothesizing? 0. So minus 0 divided by standard error. Standard error is 1.657. That is 1.657. What is the t-stat value?
I
Negative
have
7.
negative 1 point. Oh, sorry.
Go ahead.
How much is it?
Minus 7.
Minus 7. Exactly 7.
It's exactly 7.
Will it be an exact? (11.6) divide 1.657. Yeah, it's exactly 7.
Exactly.
Oh, that's great. So exactly 7. So this minus 7 falls somewhere around here, which is reject null. So what do we conclude? Reject null and conclude that the value of intercept is statistically significant. That is, it is non-zero. Conclude that intercept is statistically significant. Okay. Now what you are supposed to do is that I have done one part. Now just 1 second. Repeat this thing for the two coefficients that we have. You will be calculating it yourself. Okay. Okay. For PR and for YCS. Okay. Just 1 second. Let me open the data. Here is the data for you. Now you can do that.
I have 7.81 for
Okay.
the PR.
For YCS, it's 0.5.
0.5. So what do you conclude?
Reject the null for PR, and its
Failed to
PR is statistically significant.
Okay, PR is statistically significant. Okay, that's correct. These things are going to stay the same. Okay, so here I am not changing it. This is also going to stay the same. I am not changing it. This is also going to stay the same. I am not changing it. Okay, what we change is that the t stat value for PR will be 0.25 minus 0 by 0.032. 0.25 minus 0 by 0.032. This gives a value of what you are saying?
7.8.
7.8. Okay, this is the t stat value, and since this lies in the range beyond, so again PR is statistically significant. Okay, now lastly about YCS. So YCS, the t stat value will be 0.14 by 0.28. 0.14, which obviously will be 0.5. This is not statistically significant. So YCS is not statistically significant.
Hey, Mohit, I'm always confused on testing finding the 10% significant level. And when we do a two-tailed test, we're not doing a two-tailed test for the 10%, but we're dividing the 10% by 2 for
Yes.
5%.
Yeah, whenever you are doing a two-tailed test, then whatever the significance level you are testing, it will be divided by 2, because you are checking both the tails. So 5% window on this tail and 5% significance level on the left tail. That is why it gets divided, and our testing is done on 5%. But if this would have been a one tail test, then the entire 10% will go either on the right tail or on the left tail. So when it would have been one tail, you would have tested only at 10% for one tail. So the thumb rule is that the significance level stays the same, but if you are testing for one tail, then you will check in the table for the entire value of significance. But if you are doing a two tail, then you will check it for the half the value of the significance level. Okay. Next is the p-value method. The p-value in multiple regression. The logics of p-value is not going to change. The way you learnt the p-value in the reading 1, which is Introduction to Linear Regression, that is going to stay the same. What do we know about p-value? P-value is the smallest level of significance for which null hypothesis can be rejected. The smallest level of significance. That means if the significance level is below the p-value level, then we will not be able to reject null, we fail to reject null. Okay, just keep this thing clear in your mind that p-value is the smallest level of significance for which null can be rejected. So if p-value is lower, the significance is lower than that actual significance at which we are testing, then the value will automatically be rejected. Okay, in exam, when you are dealing with multiple regression, although when students deal with simple regression or hypothesis, they don't like p-value much. But when you are dealing with multiple regression, then the best thing that you can expect in exam, or the easiest thing, is p-value. If they give you p-value, then you don't need to perform any test. You can just look at the p-value and compare it with the significance level and instantly take a decision whether we reject null or we fail to reject null. So this is the beauty of p-value, and you are required to be pro to this, and this is not a complicated concept at all. This is a very simple concept. Okay, so the meaning of p-value is very clear. P-value reflects the lowest level Okay, so the decision rule is p value is less than the significance level, the null hypothesis can be rejected. Okay, and if p value null hypothesis can be rejected. So p value is less than the significance level because p value reflects the lowest level of significance. So if p value is lower than the significance level, null can be rejected. That means researcher wins. That means researcher wins. And if p value is greater than the significance level, then we fail to reject null. Fail to reject null. And that means what? Researcher loses. Okay.
The significance level is given to us. That's not what we find in the chart.
No, that will be given to you in exam.
Okay.
Okay. Let's take an example. Yeah. Yes. I think this should be straightforward. You don't need to do any calculation. You just have to look and answer. Which one is statistically significant and which one is statistically insignificant?
X1 and X3 would be significant because they are the p-value is less than 0.01.
Okay. And the intercept and the X2 you are saying will be insignificant. Okay. And others, are you able to conclude the same thing?
Yes, I agree.
Okay.
Me as well.
Okay. That's fine. So just to write over here that X1 and X3 are statistically significant as the p-value is less than the 0.01. Okay. Intercept and X2 is statistically insignificant or not significant. It is not statistically significant, rather that should be the word. Not statistically significant. Okay. This was testing the model to check the statistical significance of the coefficient. There may come a situation where we may not be required to, suppose we tested the statistical significance and we concluded that for all the factors that we are considering as part of our model, it is statistically significant. So none is insignificant. The factors that we have included are perfectly fine. However, it may require us to perform a second level of test. And the next concept that we are moving on to is whether the value of individual coefficient that we have determined, is it making sense or it should have been lower or higher. So it is clear that PR is the determining factor, or PR is a statistically significant independent variable for EG. It is clear that YCS is also a statistically significant measure for EG. That is clear. The first layer is achieved, assume. However, the question arises is that whether your coefficient value, is it making sense or is it not making sense? That means you are using a coefficient of say 0.25 for PR. Is it right? Or it should be lower or higher? You are making using a coefficient value of YCS. Is it 0.14 range correct? 0.10 range correct, or it should be lower or it should be higher? That is the second order of test that we can perform. The methodology will be 100% same. That is the statistical that will use t-test because it is a individual coefficient test. Everything else is going to be 100% same. The only difference will be that our hypothesized value, which was 0 over here, it will change to maybe a 0.2, a 0.15, 0.30 or something like that, and which will result in change in the t statistic value, etc. And the second change can be if we are using a greater than or a less than sign. If we are using equal to, then again it will be a two-tailed test, but if we are using a greater than sign or a less than sign, then it may turn out to be a one-tailed test. So this is the only difference between what we have performed just now and what we will be performing now. Otherwise, each and everything, the steps that we have followed, each and everything is going to be 100% same. Okay. Let's, yeah.
Where do we get the p-value? Is that in a chart or do they give it to us?
No, that's not in the chart. Actually, if you recall that hypothesis lecture, you will get. So, what we do is we calculate the t statistic value. We calculate the t statistic value for which we will be able to, we will fail to reject null. Okay. This is a reverse calculation, reverse tracking. What we do is we calculate the t statistic value, and then we check that t statistic value or the z value in the z table to calculate the range or the level, that means the confidence level at which this particular value is mapping, and we use that to calculate the significance level. Suppose this is the t statistic value, that is 7. Now what I will do is I will look for 7 in the t table. So for example, if you open the t table, just open the t table once and take this 7.8. Take this 7.8. We were testing at 10% two tail. So look at the 5% column and see where are you getting 7 point. No, sorry. Look at the degrees of freedom. So 40 was our degrees of freedom. So look at the row in the degrees of freedom and see where in the range you are getting that 7.8 value or near about value. See, even at 0.0005 level of significance, even at 0.001, even at 0.001 level of significance, the t value is 3.551. That means my p value would be much even lower than this 0.001 in a two-tailed test. This is how p value is determined. So you calculate the t statistic value and you look or find for the t statistic value in the t table, in the degrees of freedom row. For example, check for 0.5. Where are you getting 0.5? 40, and the first value is 1.303. So even at 20% significance level two tail, 20% significance level two tail, this value is lower than that. That means this would be 32 or 30 or 32% value in real terms. That range of table is not available to us, but that is an indication that this is how we find the p value.
Why don't we just use one method? Why do we have to go backwards? If it's the same, if it's really the same test.
It is the same test and the conclusion will be same, but based on the statistical convenience, p value and test statistic both are used. So p value, as I told, p value will be more easy from a statistician point of view. P value will be more easy because just by looking at the two values you can easily conclude whether it is statistically significant or not. But the t statistic is something which lays down the foundation for p value. So if I, as a curriculum, if I directly give you p value, you will never be able to understand where is it coming from and what is the essence of it. That is why here we have to learn both. But as you will move ahead in your career, the need for performing a t statistic test or etc. will go down and the usage of p value will go up.
Okay, thank you.
Okay. Yeah, so let's take an example. I think this is clear. So let's take an example. Yep. Perform the test and tell me.
I'm sorry, were we using the intercept and then the PR and then the YCS? All of them?
No, this question specifically mentioned to calculate
Oh,
for
just
PR.
PR. Okay.
Should I open the data? I think that would be helpful for you, right? Okay. Yeah, this is the data.
One 1.6.
1.6. No, I mean, what is the conclusion? Is it different? Is it not different? We reject null or we fail to reject null?
We fail to reject the null because it's between minus 2.02 and 2.03.
That's correct. And what is the conclusion of that?
So that means it's not statistically significant.
That means it is not
Coefficient
statistic.
is not.
Yeah, the coefficient is not statistically different from 0.20. The coefficient, not statistical significance, because statistical significance is whether it is 0 or non-zero. Now we are understanding that I have given a proposed value that you are showing that the coefficient is 0.25. I am giving a near about value, say 2.20, and I want to prove that whether it is significantly different from 0.20 or not. So this is rejected. This means that the coefficient of PR is near about 0.20. It is not statistically different from 0.20. That is what the conclusion we draw.
But isn't the critical value the 2.457?
To critical value to no, because at 5% significance level, it will be a two-tailed test.
I'm sorry, 2.423. It's a two-tail test, and isn't it?
Yeah.
There's no. Oh, I'm sorry. I'm looking at the no. Yeah, I'm sorry, I'm looking at the wrong one. Okay.
Yeah, just one second, let me check it. 0.05 2 tail, and in front of 40 it comes to 2.021, and here only we have calculated that, and we told that let's take it as 2.02, 022, whatever it is, 2.022. So this range is not going to change for this particular question. Okay. Now, yeah.
Sorry, Michael. Okay, I'm sorry. Mohit. So the 5% significant level, if I look at the T distribution, this is where I'm getting confused. If I
Right.
look down, I have to look for a two tail, which is 0.025, correct? Because
No,
that's a two tail.
no. When they mention it as two tail test, then you can look at the significance level that is given in the question.
Oh,
That
okay. Yes.
automatically captures everything.
Okay.
That automatically captures everything.
Okay. Okay. Thank you.
Yeah. So just to be clear, that when you are calculating two tail 5%, we are looking at below two tail in the T table. In the T table, we are looking at below two tail 0.05, 0.05 only, not 0.025, below that, and in front of 40, because 43 is not there. So in front of 40, we are looking at the value which is coming at 2.021, 0.021. And now, because instead of our actual degrees of freedom were 43, so I have told you to take an approximation of 2.022. Even if you don't do that, it doesn't matter, because that's not significant. Okay. Now coming to the example, the solution is that okay, HA is, what do you say HA? Although we first mentioned H0, but that's fine. HA is that coefficient BPR, that is coefficient of PR, therefore does not equal to 0.20. Okay. 0.20, H0 is BPR does not equal to 0.20. This is what we are testing. Okay. Next is what's the next? Yeah. Next is the T critical value. We have already calculated, that is 2.02. So the range is determined.
Mohit, just one question. We
Yeah.
wanted to test that its PR is equal to 0.20, right?
The null hypothesis is that PR is, oh sorry, I have reversed this. Sorry. So the null hypothesis is PR is equal to, the actual test that we performed is, it is not equal to 0.20, because the alternate is point, and then automatically the null is equal to, right. So this is not equal to, and then it is equal to, that is what we are testing. And again, that logic is same, minus sorry, this is plus 2.022, and this is minus 2.022. okay. Here this region is fail to reject null, and this region is reject null, right? Now we calculate the T statistic value, and this will be a two tail test because it is a equal to sign. Okay, so the T statistic value is 0.25, which is our estimate of coefficient, minus hypothesized value is 0.20, divided by standard error. Standard error is 0.032. When you calculate it, you will get the value. What value are we getting?
1.56. The null hypothesis will always be the equal, right? And then the will always, okay.
Yeah, it's simple. Whenever it is a equal to sign over here, it means two tail. Whenever it is greater than or less than sign, it will be one tail. Okay. However, there will be one exception that we will discuss when it will come. But for now, let's continue with this flow. Okay. T statistic 1.56, etc. Okay. Now what we get? Yeah, 1.56 is between this. So the 1.56 is somewhere between this range, 1.56. So we fail to reject null. So conclusion is we fail to reject null and conclude that, what do we conclude? We conclude that it is statistically significantly different from 0. Sorry, 0 I'm saying. It is, we fail to reject null and we conclude that, sorry, it is BPR is equal to 0. That BPR is equal to 0.
Does that also mean that it is statistically insignificant?
No, no, that's what I was saying. Statistical
opposite.
significance, no, statistical significance means you are testing it for 0. If the coefficient of any independent variable is equal to 0, then it will be statistically insignificant. Here it is not about statistical significance, it's about a particular value testing. The statistical significance test has passed and now we are testing it for a particular value, that you say that your coefficient was 0.25. We say that let's test it at 0.20 and say if it is not equal to 0.20. So trying to find the right coefficient kind of a thing this is, but this is not statistical significance test. That test means you are testing it for 0. Okay, now let's take another example. Yep, go ahead. First frame the HA and the H0. Did we get an answer?
Mohit, so if we have a t value, I mean, our t value is 2.42 and it's a one-tailed test.
Okay, okay,
So,
okay.
I mean, when are we rejecting the null hypothesis? If our t statistic is less than 2.42?
That is what you have to like. Okay, so let's frame the null hypothesis first. So H, okay, 1 second. Solution. What does the question say? Using standard example, test the null hypothesis that the intercept term is greater than equal to. So H0 is H0 is greater than equal to minus 10%. Greater than equal to, okay, and automatically HA will be less than minus 10%. This would have been HA. That's why this is H0. Now let's check for the T critical. So the T critical at this is what test? Is it a one tail or a two tail?
One tail.
One tail, because you are using a greater than and a less than sign. So it's a one-sided test. So one tail and the significance it at 1% significance, 1% alpha. The T critical value that you get is, if you look at the table, yeah, if you look at the table, then one tail below 0.01 and the degrees of freedom is 40. So one tail 0.01, 40, it comes to 2.42.
Right.
It comes to 2.42. We are ignoring that 0.03, 2.423 or 45, something kind of that. Let's take it as 2.42. Okay. So now the question arises is that how you will consider this one tail test. Okay. Now check the T statistic, or first frame this equation. Okay. Since this is a one tail test, which side, first you have to see the direction on which side the hypothesis is and which side the alternate the researcher hypothesis is. The researcher hypothesis direction is on the less than side and the null hypothesis direction is on the greater than side. Okay, that means that if the value, and this is negative, the values that we have over here is negative, 10% is negative. So that's why this value, the T critical value that we will take, will also be negative. Since this value is negative, had it been positive, this value would also have been positive. But since this value is negative, our value will also be negative. So the T critical value that we will take for consideration is minus 2.42. Minus 2.42, and the direction will be in same as what each and every null and this is concluding. So the null hypothesis says, or null hypothesis will be correct if it is greater. Null hypothesis will be correct if it is greater. That means what? That means what? That we should reject the, we should fail to reject the null hypothesis in this region, which is greater than the minus 2.42.
Okay.
We will fail to reject the null, and we will reject the null if it is less than, which is what the researcher is also saying, that it is less than minus 10%. So the direction will be same as what the researcher and null is saying as per the equation. That's why I told frame the null and alternate accurately at the start, because that is going to determine how you will do that. Okay, and this side will be reject null. Now you can calculate the T statistic value. The T statistic value is minus 11.6, which is the our value, estimated coefficient value, minus hypothesized value minus 10 divided by standard error. Now what is standard error? Standard error is
1.65.
1.657. Okay, which is equal to, yeah, what is the value?
Is it minus 11.6?
It's a
plus
minus
10?
of minus, yeah, minus of minus, minus of minus 10, yeah. That means minus 11.6 plus 10 basically.
I have minus 0.966.
Minus 0.966. 66, is it?
Yeah.
So
Or
it will be
656. Mhm.
656, it will be 0.97 then,
Okay.
because then it will be 0.97. If we take two digits, so 0.97 and this is 2.42. So this is falling somewhere here, which where this is falling somewhere in this range, less than the, this is falling somewhere in this range, 0.96, 0.97. Just one second. 0.97, correct? Because minus 2.42 is lower than minus 0.97. Negative number is there, so that's why. Okay. So this is failed to reject null. So we failed to reject null. Hence, we fail to reject null. And more importantly, what do we conclude when we fail to reject null? And conclude that, and we conclude that intercept is greater than or equal to minus 10%. Is this clear or is there any confusion? This interpretation is important. Yes. No doubt, no confusion. It's clear.
Actually, what are we actually saying here? Because when we're testing this and we're rejecting it, but we're testing it against the problem in the book at 11.6. Like, I'm trying to understand what this is testing, that I'm testing it against 11.6.
No. So as per your research, as per your background data, you concluded that the intercept value should be minus 11.6. Correct?
Yes. Mm-hmm.
Okay. Now we tested the statistical significance over here for this intercept and we concluded that it is statistically significant. That means it is non-zero. First leg is cleared. Okay. Now second leg is to check whether the minus 11.6 is correct or there is some variation around it. That is what we are trying to understand now, that the value that we have concluded minus 11.6, is it making sense or the value can be materially different from minus 11.6. Are you getting my point? This is what we are trying to understand, and that is why we have taken a near about number of 10%. Then we will repeat this. If suppose this test would have been passed, we will repeat it for 11%, and then we'll repeat it for 12% to check whether the 11.6 is actually correct or we need to revisit our value. So the equation is formed, the intercept is statistically significant, but if suppose the value is, instead of minus 11.6, the true value is 9, minus 9, then my outcome or my predicted value will be impacted by this, because I will be predicting based on minus 11.6, but the actual prediction should have been made supposedly based on minus 9. To check that minus 11.6 is correct or incorrect, I am performing this test using various numbers, using minus 10, then we may repeat it at minus 11 and minus 12 to conclude that from every end our number is also correct. This is the purpose of this test. Are you getting my point?
So we fail to reject at the greater than negative 10%. So we keep on doing these tests until we get reject null.
No, it's not about reject null. See, it's about suppose you predicted the share price of, let me take another example. You predicted the share price of Cardinal Health at $85. Okay. First you predicted the value. What you are doing is, first you are trying to predict that the share price is a positive value. It is not zero. Because if the share price is zero, that means the company is delisted. There is no point in analyzing that company. Correct? So the first leg that you performed was check whether it is a non-zero, whether it is a listed company, kind of a thing. You checked, you got that answer that it is a correct, it is a non-zero. The second leg would be that I am thinking that the value is, it should be 85. But it is non-zero, that is also fine. But it can so happen that I am thinking it is 85, but it may be 75, 65 or 95, 105. So to check that whether the number that I have concluded that is also correct, I am performing another level of test using 80 as a near number. So whether my hypothesis is that whether the share price of Cardinal Health is greater than 80, because if it is greater than 80, obviously my chance of 85 is more accurate. But if the researcher says or the hypothesis says, no, it is not greater than 80, then it raises a question mark on my 85 value. That is my predicted value. Are you getting my point, what I am trying to say?
I mean, I think I get it. I'm just a little bit confused about the greater than, less than. Why are you testing it?
Don't be confused about greater than, less than. The sign is immaterial. First understand the logic that why are we testing this? We are testing this because we want to be sure. See how you will do the predicted value, how you will calculate the predicted value using this equation, which is our original equation. Using this equation, you will calculate the predicted value, correct? For EG10, and using this, you will put a trade, correct?
Yeah.
That is what the purpose of this analysis is. That we want, at the end, we want to execute a trade based on this particular analysis. You to calculate the exact value, first thing that is important is that you use the correct independent variable. If suppose I use growth of tree over here, suppose I use growth of tree as an independent variable, is it making economic sense to the EG10, the S&P 500? What I am trying to say, if tree grows by 1%, then the S&P 500 is going to increase by 1%. Is it making sense? It's not making sense, because growth of tree and S&P 500 index value is uncorrelated. So first leg is taking the correct independent values, independent variables. Okay, you have selected the independent variable according to you, created the equation. Now you have to test it as well. I thought that payout ratio is an important factor, but it may so happen that the payout ratio may not be an important factor, correct? So to do that, what we do is we perform the statistical significance test. The statistical significance test says that check whether the coefficient is 0 or non-zero. If it is 0, then automatically this entire terms becomes 0, e.g. is not impacted by PR. Correct?
Mhm.
So that is why we perform the statistical significance test. We concluded. So we concluded for PR over here that it is statistically significant. That means the independent variable makes sense to be included. Okay.
Right.
Now, two legs are cleared. First is including, second is statistical significance. Now the third is that when I will use this model to predict the EG, I will put a value, forecasted value of PR, say for example 0.5 dividend payout ratio or 0.5. But the point is that when you will multiply it by 0.25, you will get a value and you will use that value to execute your trade. Correct? Actual trade. The point that we are now trying to check is whether this 0.25 is correct or incorrect. 0.25 is materially different from 0, we have concluded. But whether it should be 0.25 or whether it should be 0.15 or whether it should be 0.35. That is what we are trying to understand.
Okay.
Okay. To do that, what I do is I took a near about number. The near about number is test whether it is greater than 0.20, because if it is equal to 0.20, it is near to 0.25. But if it is does not equal to 0.20, then it means it is statistically different. So that is the testing we are doing. Here we prove that we fail to reject null. Fail to reject null means that H0 is near about 0.20. It is equal to 0.20 and 0.20 and 0.25 are nearly same. So we concluded that. That is what we are trying to aim or achieve with the help of this. Similarly, over here, we are trying to understand that my intercept value was minus 11.6. And I am trying to check whether it is greater than 11 minus 10 or less than minus 10. If it is greater than minus 10, that means it is in line with that. So here what we are testing is we fail to reject null. The conclusion is we fail to reject null and we conclude that the intercept is greater than equal to minus 10. Greater than minus 10 means it should not be near 11.6%. That means I need to revisit my numbers again.
Okay, so then the original equation, you can't use the 11.6.
Ideally, no. Ideally, no. That means it requires the analyst to revisit the equation, revisit the data and check for the 11.6.
Okay, and then that goes also for the 0.25.
0.25 also, if you are
Okay.
being very accurate, then it should be near 0.20. So check for the data again. Just to extrapolate it a bit further, here, if we would have rejected null, that would have stated HA is less than minus 10%. That would have been in line with my 11.6. That okay, if it is less than 10%, it will be minus 11.6. Correct?
Yes.
Okay. The last LOS that we have for today, which is a simple LOS, and we have practically already discussed this thing, is LOS-E. This is nothing but you will be given an equation and you will be given the values of the independent variable and you will be required to calculate the predicted value. This is something which we have already done over here. I gave you this equation, then I gave you the value of GDP and interest rate, and we calculated the value of share price value of Cardinal Health over here. Right? In similar tone, it will also be there. That you will be given the value equation and the values of the independent variable, and you can calculate the value of the predicted value of the dependent variable. So this is something which is very easy. No hi-fi knowledge is required. Very straightforward. let's do an example. So using example 5, I think, using the standard example, calculate the predicted value of EG10 if PR is 50% and the YCS is 4%. Okay, just note that a hat sign will be included when you are actually calculating a predicted value. So using the original equation, you would say using the equation EG10 hat is equal to minus 11.6 plus 0.25 into PR plus 0.14 into YCS. That was the equation. So here now you can just put the value of 50 and this one 4. So minus 11.6% plus 0.25 into 50 plus 0.14 into 4%. What is it?
1.46%.
1.46%. So this is the predicted value. So that means the earnings growth rate of S&P 500 is expected to be 1.46% if the payout ratio is 50% and the yield curve is trading at 4%.
How do you know to keep it in percentage and not just change it to decimal? Because if you change it to decimal, then the value is different, correct?
So if you change it to decimal, you have to change all to decimal. One
Right.
cannot be in percentage, one cannot be in decimal. And second, the unit measurement will be clearly given in exam along with the equation. So you have to just follow that unit measurement. Instead of percentage, it could have been amount also. So if they mention amount, they will mention the trillion or quadrillion, whatever it is, or billion. So it's suppose 1000 billion. So you have to be sure of that you are using the same unit, and just that's it.
Okay.
Okay. Any other question? Any other doubt? No question, no doubt.
So this is, you only plug it in after you've proven that your coefficients are statistically significant.
Sorry, this is?
So you only plug in these values, like just theoretically, you only plug in these values if you as an analyst prove that the coefficients are statistically okay.
Significant, because if it is insignificant, then you will have to revisit the data and rephrase the equation, removing that independent variable, ideally.
Okay.
Okay. Then in that case, if there are no other questions, we are done for the session for today.